Welcome to EDU World Space.
This question asks us to consider the Mg2+, Cl-, K+, and Se2- ions, and it shows us these four spheres, and it asks us to represent each of these ions with these spheres without looking at one of the figures in the text. And then it asks us to consider two other ions in part B, but we'll get to that in a second. So it wants us to match these ions with these sphere sizes. So the first thing I'm going to do is look at what the electron configuration of these ions is in terms of what noble gas they represent. So for example, with magnesium, if you remove 2 electrons, you would have the same number of electrons as the noble gas neon. In chlorine, if you gained an electron, you would have the same number of electrons as argon. Potassium, if you lose an electron, you would also have the same number of electrons as argon. And selenium, if you gain 2 electrons, you would have the same number of electrons as krypton. Okay? And then I want to look at the atomic numbers of each of these. Magnesium is 12. Chlorine is 17. Potassium is 19. And selenium is 34. Okay. So at first we can see that the number of electrons that these ions have, we can just compare relatively the size of the noble gases. As you move from top to bottom down the periodic table, the noble gases get bigger. So it would go neon, then argon, then krypton. So I'm already going to put in magnesium 2+ here. Magnesium 2+ and selenium here, because I know neon is the smallest of these and krypton is the largest of these, so these are definitely the smallest and the largest respectively. But it becomes a little bit, takes a little bit more consideration when we look at chlorine and potassium, because they both have the electron configuration of argon. So we need to see if they have the same number of electrons, what is different between these ions, and that's the atomic number. Chlorine has 17 protons, potassium has 19 protons. So because potassium has a larger number of protons, it'll have a greater effective nuclear charge, a greater attraction with its electrons, and therefore a smaller atom. One more time, higher atomic number, more protons in the nucleus, greater attraction between those protons and electrons, shrinks the atom down, smaller atom. So that means potassium would be next, and chlorine would be after that. So this is the general trend, just based on some general rules about size, so we can rank these from smallest to largest. So that's part A. Put a little A here. And part B says it wants us to consider two other ions. We have, I'm going to list these over here, Ca 2+ and S 2-. Okay, calcium losing 2 electrons is represented by argon, and sulfur gaining 2 electrons is also represented by argon. So again, this is going to work out in this confusion here where these atoms go. And the atomic number of calcium is 20, and the atomic number of sulfur is 16. So just like before, the rule is that larger atomic number means more protons in the nucleus, more attraction to the electrons outside the nucleus that brings those closer together, and it shrinks the size of the atom. So higher atomic number, lower atomic radius or smaller size if the number of electrons is the same. So calcium has more protons than potassium, so that would mean that calcium would fit right here. And sulfur has 16 protons, which is less than chlorine. That would make it larger than chlorine. So sulfur would fit right here. So again, the general rule that we're working with is if the number of electrons is the same, higher atomic number, more protons in the nucleus, more attraction to the electrons, smaller atom.